Welcome back. So now that we have an understanding of how to find probabilities from specific z-scores on a standard normal distribution, we're going to reverse that and look the other direction. So we're going to try to find z-scores based on areas, aka probabilities. So we're reversing this whole process. So we still want to draw a bell-shaped curve and identify the region under the curve that corresponds to the given probability. If that region is not a region from the left, so if it's not shaded to the left, work instead with a region that is a region to the left. So if it's shaded to the right, basically look at it from a left-hand perspective. All right, we'll see what that looks like with some specific examples. Once you've done that, then you want to use the table in reverse. So you first have to find the probability in the body of the table, and then you work your way out to the edges to find the z-score. So it's a little clunky, but hopefully you'll see what I mean once we do a couple problems. So let's take a look at number 8. Find the indicated z-score. The graph depicts the standard normal distribution with a mean of 0, standard deviation of 1. All right, so that's what we have to work with. Now, the one thing we notice is that we have some area here, or probability, underneath the curve. It's on the left-hand side of the z-score in question. So that's a good thing because then we should be able to try to find something directly on the table. Now, the question is which table should we use? Should we use the positive z-scores or the negatives? Well, where is the z located? We know 0 is right here, so z must be positive. There's no way around it. So we have to look at the positive z-scores. So 9, 7, 9, 8. So we're trying to find that somewhere in the body of the table. 9, 7, 9, 8. 9, 7, 9, 8. Aha, there it is. So we got to do our process in reverse. So if we go all the way out to the edge, we know the first part of our z-score is 2.0, and then what's the second part? So if we go up to the top, 0.05. So we basically got to just smash those two pieces together to get our z-score. So we should end up getting 2.05. Now another way to think of it is you can add those two pieces together and that will join them together into an overall z-score. All right, let's do the next one. So they're giving us our picture. They're giving us this little corner over here is 0.1075. So the first question is, should we just run to our table and look for this value in the body of our table? Oh, where's my buzzer? No, we're not going to want to do that because this is area to the right. We want area to the left if we want to use our table. So how do we find this area to the left? We can use our complement rule. So our complement rule says if we said 1 minus the area on the right, that should give us area to the left. So 0.8925 should be this area. And now, again, our z-score is on the right-hand side of the middle, so it should be under the positives. So let's look it up. 8925. There it is, 8925. So what's our z-score? Well, 8925, so 1.24. 1.24. And that's it. So it's not too terrible, but you just got to make sure you're using the table correctly and using it in the opposite direction. So if you're looking for a z-score, you start in the middle and work your way out to the edges. If you're looking for a probability, it's the reverse. You start on the edges and work your way into the middle. So let's do a few more. A little bit more wordy, as they always tend to be. So number 9, assume that thermometer readings are normally distributed with a mean of 0, standard deviation of 1. Oh, and this is Celsius, which makes me think back to the other problem. It should have been Celsius, not Fahrenheit. Oh well. A thermometer is randomly selected and tested. In each case, draw a sketch find the temperature reading corresponding to the given information. So now we're finding the temperature reading, we're not finding a probability. So looking at the first one, P95, the 95th percentile, this is the temperature reading separating the bottom 95% from the top 5%. So remember, percentiles are a measure of position. So if you're starting at 0 and you're working your way through the list, all the way 100% of the way through the list, you have those different percentiles that you can stop at. So for this one, you're starting at 0, or starting at the far left side, and then you're gradually working your way 95% and you're stopping there. What's the temperature that gets me 95% of the way through the bell? That's what they want to know. So if we draw it, it should look something like this. So again, if we're starting on the left side and we gradually work our way so that we're 95% of the way through, we don't know what that value is, but this is 95%, and then this is the remaining 5%. That's what they just told us. They want to know what that temperature is that makes that happen. So, what should we do? What do we use? Do we need to use this 95% or can we use the 5%? Well, remember, your table only works on the left side, so we need to use this 95%. This is garbage for us. So, our table, though, doesn't deal with percentages. So we need to fix that and change it to a decimal. And because it's area under the curve, we need it as 4 decimal places. So our z-score is on the right-hand side, so we got to use our positives. And so we need 0.950. So 979695, 9495, 9505. But wait a minute, what's this star? Oh, 9500. The z-score is 1645. So that's a special one. There's 2 stars. There's another star here. There's a special one. But in this case, we want the 9500, and so that is 1.645. That's the one time you're going to get, well, one of 2 times you're going to get a z-score that's more than 2 decimal places. So So 1.645 degrees Celsius is the temperature that splits it like that, a 95% split. All right, let's try the next one. If 2.5% of the thermometers are rejected because they have readings that are too high, and another 2.5% are rejected because they have readings that are too low, find the 2 readings that are cutoff values separating the rejected thermometers from the others. Okay, well, let's get our picture. So we want 2.5% on the high side and 2.5% on the low side. So I'm thinking that this is 2.5%, and we have another z-score where this is 2.5%. So they want to know what those 2 temperatures are that make that happen. Well, where do you want to start? Which one would be easier for our table to find? Remember, our table only looks to the left. This is to the right, so I don't want to start with that one. Let's start with this one. This one is shaded to the left. This is 2.5%. Okay, so we know we want to start with this one, which is going to be less than 0, so that's on the negative z-scores. But obviously we can't work with that percentage. We got to change that. So what's that as a 4-digit decimal? So 0.0250. All right, so we need to look that up on our negatives. So 0.0250. 0250. Ah, there it is. So what's that z-score? Negative 1.96. So this one, Z on the left, equal to negative 1.96 degrees Celsius. Now, riddle me this. This is a nice symmetrical graph, symmetrical bell. It's centered around 0. You got 2.5% on this side. You got 2.5% on this side. This z-score was negative 1.96. So what's your gut thought on what this z-score should be? Yeah, it's going to have to be the positive, right? Positive 1.96. Math is logical. So if you think it makes sense that it would be positive of 1.96, you're probably right. Now we can show it if we want, but the big thing is a little bit more work, because first thing we have to do is ignore all this and just worry about this 2.5%, which means all of this left side is 97.5%. Well, 97.5% is 0.9750. So 0.9750 is positive 1.96. So it does check out, but sometimes you can just kind of extrapolate based on what makes sense. So that's another thing to keep in mind. All right, so we're going to stop the video here, and we'll save the last application of this stuff for the next video. So see you in a minute.